Hi guys, we're on 10.B notes. This is page 69 in your book, and we're going to actually talk about more things that we can do with radicals. We're going to start with adding radicals, and then we'll move on to multiplying in this section as well. So here we go. I'm just going to put adding. I don't think it has it here anywhere. Adding radicals. And these are kind of like when we're looking for like terms, when we're adding variables together, or when we're adding even fractions together, and we have to have a like denominator. When you can add radicals together, but they have to have the same type radicand. And remember, this is what's on the inside of the radical symbol. That's called the radicand. So when those are like, then you can add them together. So if you're looking at what we're saying here, I'm saying I've got 5 radical 2's. All right, 1, 2, 3, 4. There's 5 of them. And I've got 3 more of them someplace else. These are exactly alike. The radicands are alike. And so we can combine them, and we can say we have 7 of those radical 2's. Except it would be 8. 8 radical 2's. Okay, here's an example of ones that you can't combine. You can't say you have 5 of anything because these radicands are different. So we're going to use that idea, and we're going to go work a few of these problems down here. Okay, so obviously this guy and this guy are the same, but he's not. So I can combine these and say I have 7 radical 6 plus 3 radical 7, and that's as simplified as it can go. On this one, you can see that the radical 10's can be combined. 3 minus 5 is minus 2 radical 10 plus 4 radical 3. And all the while we're asking ourselves, as we look at these radicands, can we simplify them further? Do we have a perfect square in there somewhere, like we did in simplifying our stuff in 10A? We're going to get there. All right, so here we have 4 plus the ghostly 1. There is 1 radical 5 here. That makes 5 of them, and we're taking 2 of them away, so that leaves us with 3 radical 5. And over here we have 2, and we're taking 1 away, so that leaves us with 1 radical 3. Okay, so let's go down and do a few more that have a few more steps. Again, we're going to make sure that before we say we've got our answer, that everything is simplified underneath the radical sign. So on first blush, it doesn't look like we can do anything. Radical 3 and radical 27 do not have the same radicand. And you might say, well, I can't do anything, and I'm going to move on. That's my answer. But radical 27 is not simplified yet. So he is going to be thought of as radical 9 times 3. And our property says, well, I can split that up. I can say, all right, well, that's radical 9 times radical 3. And of course, radical 9 is 3. So when we do that to simplify it, we end up with this. And now, of course, our radicands are the same. I've got 2 of them here, and I add 3 more, and that leaves me with 5 of those radical 3's for my final answer. Both of these radicals can be simplified. I can think of 20 as 4 times 5, and I can think of 45 as 9 times 5. So radical 4 comes out as a 2, and radical 9 comes out as a 3, leaving radical 5 in both cases inside the radical sign. And because those are like terms, we can say, I can combine those, and 2 minus 3 is minus 1, and we'll just write it minus radical 5. Okay, this one. So again, I'm looking inside the radical sign. 18 is going to be written as 9 times 2. And 50 is 25 times 2. Now we can simplify that and say that's 3 times 3 radical 2. There's the first 3 right there, and here's the square root of 9 right there on the outside. Minus 6 times 5 radical 2. So these are coefficients that are out in front. They just stay there, and then they'll multiply nicely once you bring something else outside the radical sign. So that becomes 9 radical 2 minus 30 radical 2, which gives you 21, negative 21 radical 2 as your final answer. These are kind of fun, huh? All right, this one's harder, and I'm not sure. I'm going to run through it really quickly. I don't know that you've really had enough practice with this yet to do this, but since it's on here, I'll show you what I do with it. Remembering you cannot leave a fraction inside a radical sign and consider it simplified. So we need to split this up and say this is radical 5 over radical 11, and we need to rationalize the radical 11. So this looks really messy, but you can do it. So this is minus 44. We can multiply the 5 times 11 and get 55. And of course, radical 11 times radical 11 just comes out as an 11, which is great. So now we have radical 55 minus, and 11 goes into 44 4 times. And now we can combine these. 1 radical 55, take away 4, you get minus 3 radical 55 as your simplified answer. This is just to remind you that you cannot leave a fraction inside a radical sign, and when your denominator has a radical in it, you have to rationalize it by multiplying by this funky form of 1. Radical 11 over radical 11 is just another way to name 1, and we can multiply this by it because we can multiply anything times 1 and not change its value. Okay, we'll pick up on the next video. Bye.